All right, so today we're going to be talking about 3.7, which we're looking at law of sines, law of cosines, and areas of triangles. So the first part of this video, we're going to be looking at law of sines. So a few things that we need to know is that previously we looked at how we could use sine, cosine, tangent to solve a right triangle. Now we're going to be looking at non-right triangles. So these are what are called oblique triangles. And so a few notes to make. You'll notice that all of our angles, we use capital letters for when we're drawing our triangles. And then across from that angle is its opposite side, and that's going to have a lowercase of the same letter. So angle A is opposite of side little a. Angle B is opposite of side little b. So that brings us to our law of sines. So our law of sines can help us find a side or an angle. And we have to be given two measures in any side. So we need to know at least one of these sides. So in order to do this, we're going to take the sine of A, of angle A, over side A. That's going to be equal to the sine of B over side B, which is equal to the sine of C over side C. So these proportions allow us to solve for those missing sides. So one of the things we need to remember is because each of these are set up angle A, side A, angle B, side B, angle C, side C, we have to have a pair of angle and opposite side. So if I look at number one, we want to use the law of sines to solve these, and we're going to round all of our answers to the nearest hundredth, so 2 places after the decimal. Actually, let's make that 10th. So first off, we see I have this 47-degree angle. I'm going to go ahead and label that as A. And we have side A that's 15. So we have an angle and its opposite side. And we can use that to find the angle 104 and its opposite side of X. So we can set the sine of 47 degrees over 15 is equal to the sine of 104 degrees over X. Now that we've got this proportion, we can cross multiply and solve. So we get X times the sine of 47 equals 15 times the sine of 104, and then divide by the sine of 47 on both sides to get X by itself. So X equals 15 times the sine of 104 over the sine of 47. And now you're ready to type that in your calculator. So make sure you are in degree mode on your calculator because those angles are in degrees. And you should get that X is 19.9 centimeters. Okay. All right, number 2, same process. We're looking to find an angle and its opposite side. Well, I see 42's opposite side is X, so I know that that's going to be one of my ratios. But the only other side I know is this 28. But I can find its opposite angle because I would take 180 and subtract the 2 angles that I know. Gives me 75 degrees. So now I know the sine of 75 over 28 has to equal the sine of 42 over X. So again, cross multiply and solve for X. And you should get X equals 28 sine of 42 over sine of 75, which gives me 19.4. So we can solve for those unknown side lengths using the law of sines. So now, when we're solving for angles, there's a couple different things that can happen. So when we're solving for angles, this is where we have the side-side angle relationship. So when we think back to our congruent triangles, what made our triangles congruent using like angle, side, side, hypotenuse, leg, those 5 theorems, was the fact that it would always make one unique triangle. So if we had those relationships of sides and angles, our 2 triangles had to be congruent. But here, side angle doesn't work because I have the possibility of making an acute triangle and an obtuse triangle out of any combination of side angle. So I could create a triangle that looks like that, or I could create a triangle that looks like that both has side angle. And when we do that, it doesn't make one unique situation. So this is called our ambiguous case. Okay, and this is when we're solving for an angle using the law of sines. Okay, so when we have this, we have to remember that all of our sine functions always have a sine ratio between -1 and 1, right? We had ratios of 1/2, √3/2, √2/2. All of those values are between -1 and +1. The angles where sine is positive could be in quadrant 1 or quadrant 2, right? Quadrant 2 would be where our obtuse angles would be, right? An angle that's in quadrant 2 has an obtuse angle, an angle between 90 and 180. So anytime we have side angle, to find our other possible angle, we're going to subtract the angle that we get from 180. And if that angle works with the angle that I'm already given in the problem, then there's another possible way to build that triangle. Couple things. All 3 angles always add up to 180, and no triangle can have 2 obtuse angles. So we can't have 2 angles that are greater than 90 degrees. All right, so when we do this, there's a couple different things that could happen. This is going to give us one possible triangle. So I'm going to go ahead and draw this. And so as we're drawing this, remember that A, B, and C, we're looking at angles and opposite sides. So I'm just going to go ahead and label this. It doesn't have to be drawn to scale. But I've got A, B, and C. C is 102 degrees. Side C is 24, so that's its opposite side. And side B is 21. So I have that side angle relationship. So I am still going to use law of sines because I've got an angle in its opposite side. So sine of 102 over 24 has to equal the sine of B over 21. Cross multiply. So 24 times the sine of B equals 21 times the sine of 102. Divide by 24 on both sides. So the sine of B is 21 sine of 102 over 24. And I'm going to go ahead and find that as a decimal. So when I do that, my reason for doing that is because if this fraction is bigger than 1 or smaller than -1, I know it's not possible. So when I do that fraction, I get 0.8559. So now I'm just going to take the inverse sine, right? I'm trying to solve for an angle, which means I need to take the inverse sine of that ratio. Okay, so I'm going to inverse sine both sides, and that gives me that angle B is going to be 58.9. So I ask myself, is there another option? If I take 180 and subtract what I just got, 58.9, that would give me the other possible angle for angle B. So when I subtract those two, I get 121.1. And I ask myself, if I use that 121.1 and the 102 angle, am I less than 180? And that answer is no. So that means that there is not another triangle that's possible. There is only one possible solution, right? I got an obtuse angle already in my triangle, which means that another obtuse angle is not possible. All right, so let's see what happens when we've got two possible triangles. So same process, I'm going to go ahead and set up my triangle, label my angles, and we know A is 60 degrees, we know side A is 27, and we know side C is 30. So again, I've got side, side, angle. So I'm still going to solve everything just exactly how I was because I have an angle on its opposite side. So the sine of 60 over 27 has to equal the sine of C over 30. Cross multiply and simplify, and you should get the sine of C is going to be equal to 30 sine of 60 over 27. You may have a step or two more, and that's okay, but we should get to that place. So now I ask myself, is this value between -1 and +1? And it is, which means that I can find a solution. So I'm going to inverse sine both sides. So angle C is the inverse sine of 30 sine 60 over 27. So the measure of angle C should be 74.2 degrees. So again, I'm going to ask myself, is there another option for that angle? So if I look at this, I take 180, again, I've got side, side, angle relationship. So 180 subtract my answer that I just got, which is 74.2. I subtract that and I get 105.8. If I have an angle of 105.8 and a 60-degree angle, because I know that 60-degree angle has to stay, is that less than 180 degrees? Meaning, would those two angles work in my triangle? So is 105.8 plus 60 less than 180? So the answer is yes, which means that the measure of angle C could also equal 105.8 because that was the obtuse angle in the second quadrant. All right, so one more. Now we're going to see what happens when we've got no possible triangles. So set up your triangle, A, B, and C. Angle C is 89, side C is 26, and side B is 34. Again, side-side angle relationship, angle in its opposite side. So I'm going to do the sine of 89 over 26 is going to be equal to the sine of B over 34. Cross multiply, and you should get the sine of B is going to be equal to 34 sine 89 over 26. Now we're going to inverse sine both sides. And when I inverse sine both sides, I get the measure of angle B is an error. So it gives me an error in my calculator. That tells me that there's no possible solution. What also happens is if you find what this fraction is as a decimal, that 34 sine 89, that gives me a decimal of 1.307, which is not possible. I can't take the inverse sine of a value greater than 1. Okay. All right, great job. That concludes our law of sines portion. Thank you very much.